Okay, now we're going to look at trig equations and general solutions. If you have something like this, sine theta equals 0.45, and you're asked, solve, find out what theta is. It's so easy. You go shift sine of 0.45. You put that in your calculator, and it tells you the answer is 26.74 degrees. Well, there's your answer. You've solved the equation. But the thing with sine is it repeats itself every 360 degrees, and that's what this k times 360 does. You can add 1, 2, 3, 4, it comes back to the same place, or minus 1, minus 2, you get all these different solutions. And if 26 works, then 180 minus 26.74 will also work. It's in the second quadrant, it's positive, it gives you the same answer, and you have to know that for sine. That's how it works. Now, what if you saw something like this? 1 minus 2 sine squared. Look on that formula sheet. 1 minus 2 sine squared. Hey, I can rewrite that as cosine 2 alpha. And they give you a mark just for doing that. Cosine 2 theta equals a half. Then you ask your calculator, or maybe you know from the special triangles, shift cosine of a half is 60. So there's two places where you'll get exactly the same answer, plus 60 and minus 60. That's how cosine works. So now we know the angle 2 theta is plus or minus 60. But we want to find out what theta is, so we divide everything by 2. And there's our general solution. Plus or minus 30 plus k times 180, 360 divided by 2. And k is an element of the integers there. Any number will work, positive or negative counting number. Now, this question's a little bit harder. You're going to solve this, but it's actually somehow a kind of a two-bracket quadratic thing sometimes. So what you've got to do is make it 0 on this side. So you subtract sine theta. And then the big thing is you factor out sine theta. And now it'll make this equation 2. You see, if sine theta is 0, whatever this is, it'll be 0. So there's one of your formulas. Sine theta is equal to 0. And the other one, sine times 2 cosine, gives me this. Sine times minus 1 gives me this. Then you make 2 cosine minus 1 equals 0. You add 1. You divide by 2. You divide by 2. And there you get cosine theta equals a half. Well, there's your two things. If you go shift cosine or shift sine of 0, it'll tell you it's 90 degrees. But you get the same answer at 270 as well. So you can say plus k times 180. If you keep spinning around just half, you'll get to 0 again. Shift cosine of a half. Hey, we've done that. It's plus or minus 60 degrees. Plus k, there it is. And that's what theta is. And there's the general solution. Okay. And let's just look at the next part. We're going to look at trig functions, graphing trig functions. I'm just going to do one example and make sure you can understand the basic things that you have to know about graphs. Like this one, f of x equals 2 sine of 2x. Well, if they ask you about the range, what does the range mean? It means all the things that y can be. So it means that y is less than 2, but bigger than minus 2. The range is from minus 2 to 2. You could put it in brackets, or y is less than 2 or greater than minus 2. That's the range. The period is, how many degrees does it take to go through a complete wave? Well, there's a complete wave, and there it is, 180 degrees. The amplitude, you have to know, it's how tall is the wave, or how deep is it, from to the top or to a trough. Well, it's 2 units in front, and it's always this number 2. Now, for the period for the basic sine graph is 360 degrees. It takes 360 to go through a complete wave. You see that little number 2 in front? If you divide it by 360, you'll get the new period, which is 180. The step for the basic sine is 90 degrees. Every 90 degrees, it goes to the top, comes to the middle, goes to the bottom. You can find all the things you graph every 90 degrees. But the step for this graph is 45. We take that 90 and divide it by 2. So every 45 degrees, something happens. We divide by the number in front of x to change our period and our step. But if you know it's 45 degrees, you know, you can if they ask you to graph something like this, it's so easy. You just type 2 a sine, the bracket 2, then another bracket on the other end, and you put in 45. And if you do, you get the answer 2. If you put in 0, you'll get the answer 0. If you put in minus 90, you'll get that point right there, minus 90 and 0. If you put in 135, your calculator will tell you it's minus 2. It's better if you understand the graph and can just graph it, but you can check on your calculator. Type the function in, put in the x values. If you've got the right step, you'll get all the right answers. It's really not so hard. And let's just take a look. What have we got here? What if I have this, 1/2 cos 3x? So how would I do it? Well, the amplitude is the number. That's how tall it is. It goes up to 1/2. It goes down to 1/2. The step, it's normally 90 degrees. Divide by 3. Every 30 degrees, something should happen. So 0, 30, 60, 90, 120. We're supposed to sketch this between 0 and 120. What's the period? 360 divided by 3. That's 120 degrees to go through a complete wave. Now I'm not sure of the points, so all I do is I put in 0. 1/2 cos 30. I just type it into my calculator. Hey, it says it's 1/2. Then I put in 30. It says it's 0. 60, it says it's minus 1/2. 90 says it's 0. And 120 says it's 1/2. You can get a table on your calculator to do it, but I think it's better to look at each point. It's even better to understand the cosine graph and know that it's going to look like this. But anyways, that's it for trig equations and a little bit of graphing. Okay.